We have here the graph of the function f of x equals 12x squared plus 4x cubed minus 3x to the fourth. For part A, we'd like to find the domain and range of f. Now here we have these arrows indicating we're going off to the left forever, and here we're going to the right and down forever. And so we need to keep that in mind when we're doing our domain and range. For the domain, we care about all the possible x values. And from our graph here, it looks like there's no restriction on x values. Okay, we can plug anything we want in because it looks like we're going to the left forever, and here this looks like we can use x values to the right forever. And so our domain is all real numbers. We can indicate that with this symbol, or we can write it as the interval negative infinity to infinity. For the range, we want to know the lowest possible y value, and it looks like it's going down forever and ever and ever. So our range, we'll say, is negative infinity up to, and then we find our highest point. And our highest point is right up here, and we don't actually know where that is because it's not indicated on the axis. But we're going to go ahead and estimate that based on the scale that's given on the x-axis here. So it looks like maybe our that's a 1, and then at 2, maybe it's a little bit more than 2. So I'm going to go ahead and estimate about 2 maybe 2.25. And that's an estimate because we don't know exactly what it is, but we do reach that point, and so we would put a bracket on that. And then we would like to know the intervals on which the function is increasing, decreasing, and constant. So this is all talking about what's happening on our graph as we move from left to right. So starting at the left, as we're moving along here, we are stuck flat here. Okay, so that is constant. And I'm just going to write it here on the graph, and then I'll interpret that and write it in interval notation over here. So we start off at constant, and then it looks like right here at -3, we're going to have a switch. And right there, we start moving up. And so moving up is increasing. And that lasts right up to this peak right here at -1. And then all of a sudden we're moving down. And moving down is decreasing. And that doesn't last for long. It looks like it's flipped strange. It's right there at 0, and it's moving up again. And so that is increasing. And we reached our peak here, and it turns around, and now we're moving down. And moving down is decreasing. All right, now we can go ahead and interpret that over here. So for first of all, increasing. For increasing, we look at where that's happening, and we put it in our intervals. So for this first one, it starts here at -3 and ends at -1. And so we have -3 to -1. And we have the interval here starting at 0 and ending at 2. And so 0 to 2. For decreasing, we see that happens right here. It starts at -1 and ends at 0. So -1 to 0. And we have another one. And that is from starting at 2, and it looks like it goes forever. So we'll say 2 to infinity. And finally, f is constant. That only happened right here. It looks like it's to the left forever. So that would be from -infinity up until right here, which is at -3, where it changes. Now you may be wondering why we use the word and here instead of the union symbol. And the reason is that the union symbol would mean that we include all that together as kind of one object. And it's not actually true that for that whole set it's increasing. For example, the x value right here, okay, the y value is smaller than for over here. And so grouping them together doesn't quite work out. Remember, the definition of a function increasing or decreasing involves just one interval. Okay, it's not a set that's a union of multiple intervals.